Hello! For this video, we will answer this problem. A 14 by 15-inch double-acting air compressor whose clearance is 4% runs at 150 RPM at state 1, as shown in the figure. The air is at 14 psia and 80 degrees Fahrenheit. Discharge is at 56 psia. Compression and expansion are isentropic. The state of the surrounding atmosphere is 14.7 psia and 70 degrees Fahrenheit. Letter A. Estimate the amount of free air in feet cube per minute using the conventional volumetric efficiency. Letter B. Compute the horsepower for a compression efficiency of 75% based on the shop work input. Okay. Sige. So, let's redraw the problem. Okay. Napipindot. Yan. Okay. So, drawing natin ulit yung problem. Yung diagram. Pressure, PV diagram. Okay. Oops. Meron tayong okay. And then, P2 daw is 56 psia. P1 14 psia. T1 80 degrees Fahrenheit. And then, P atmospheric is 14.7 psia. T atmospheric 70 degrees Fahrenheit. And then, dito sa drawing, ito yung V3 natin. And we have V1, V4, what else? V1 prime. Okay. Ito naman, this is our VD, or displacement volume. Ano pa yung given? D, 14-inch, 14-inch, L, 15-inch, C, 4%, yung root 150 RPM daw yung kanyang compression rate. So, ano natin na omega. For letter A, tinatanong yung volume ng free air in feet cube per minute. So, let's consider one cycle. So, one cycle, calculate for the displacement volume. Kasi walang binigay na yung length ng stroke. So, let's assume na yung length ng stroke ay itong length na to. Okay, walang binigay ng length ng stroke. So, if that's the case, pi times d squared over 4 times L, diba yung displacement volume. Substituting the values. So, in feet, times So we have 1.336 feet squared. For air, let's assume na since air is composed of mostly of N2 and O2, diba? So for diatomic gases, diba? If you will remember from ChE 142, this is the gamma for diatomic gases. Okay. Let's use the equation for the efficiency volumetric. So ito yung equation, diba? That we derived sa lecture. Tapos, substitute natin yung mga given. So, ang P3, that's the, ano ba yung P3? Equal lang yan sa P2. So, 56. Yung discharge pressure, 56. And then, yung P4, equal lang yan sa P1, 14. The suction pressure raised to 1 over gamma times 100, 93.23% yung volumetric efficiency. Now, this volumetric efficiency is actually equal to V1 prime over VD. Diyan natin siya, diba, dinerive at first. That's the starting equation. Therefore, V1 prime is N prime. So, rearranging the equation, so solving for V1 prime, multiplied by the displacement volume, makakuha natin yung V1 prime. 1.24 feet cube. But this is not the free air pa lang. Kasi, remember, iba yung temperature niya at saka pressure. Itong suction volume na to. Let's see kung V1 prime. What do we call V1 prime? Actual volume drawn. Iba yung conditions niya ng pressure and temperature as compared to the atmospheric. Yung free air volume kasi, it's based on the atmospheric conditions. We simply use yung combined gas law, okay, to calculate for the volume of free air. Okay, volume of, lagi napipinta. Volume of free air. So, yan yung combined gas law. Ito yung unknown. So, ito lang yung atmospheric pressure and temperature. Ito yung, actual volume drawn in, yung sinolve natin. And these are the conditions sa loob ng cylinder, P1, T1, at the suction. So, substituting the values, isolating the free air delivery volume sa isang side ng equation, substitute na natin. It's simply 1.2456 feet cube times 70 plus 460 Rankine times 14 PSIA, divided by 80 plus 460 Rankine times 14.7 psia. And we will get the volume of free air delivery na 1.1643 feet cube. Pero dyan ba matatapos yun? Hindi pa, kasi double acting yung compressor natin. Ano nga ulit? Pag double acting, yung two sides nung piston cylinder ang nagagamit. So, kailangan natin siyang i-multiply ng 2. Okay, kailangan i-multiply. Paano ko ba to matatanggal? Yan. Kailangan i-multiply siya ng 2 at the same time, kailangan mo siyang i-multiply nung revolutions per minute. Sorry ha, laging napipindot accidentally. So, that's V-FAD times 2 kasi double acting times yung revolutions per minute. So, that's equal to times 2 times 150 RPM. 150 RPM. So, that's equal to 349.3 feet cube per minute. Yan. Okay, that's letter A. Letter B. Ang tinatanong sa letter B naman is horsepower based on 75% efficiency. Tama ba? Based on, compression efficiency na 75% based on shaft work input. So, let's use the equation for work. This is just a single stage compressor. This is just single stage compressor. So, we use this equation. Okay, so, na-derive natin sa lecture. Okay. Pero, instead of this form, we can actually we can rewrite this para lang hindi na natin kailangan ng R. Okay? So, we can also use, kasi ideal gas naman yan, ilabas natin yung gamma, tas yung nRT1, palitan natin ng P1V1. Yan. But you can also use yung nRT1. I just prefer na gamitin yung P1. V1. Yan. So, substituting the values, okay, into the equation. By the way, ano yung V1 na gagamitin? So, yung V1 na gagamitin, hindi pa pala natin siya na-solve. Yung kaninang V1 prime, okay, V1 prime, yung 1.2456, multiply lang din natin ng Multiply lang din natin ng 2 kasi double acting at saka yung revolutions per minute. So, ito yung V1 na gagamitin. So, going back to the equation, ito yung gamma, okay, times 14 PSIA B1 times times convert na natin into BTU. So this conversion factor is unusual pero convert na natin. Everything multiplied by the ratio of the pressures. Para BTU per minute na siya. So, what you will get here is 1646.7 BTU per minute, or when converted to, pero this is not yet the actual work kasi this is the work if adiabatic and isentropic, if reversible. So, you use the efficiency, work actual, okay, iba yung efficiency for compressor, work shaft over work actual, work isentropic over work actual. So, therefore, yung work actual ay, and this is, correct natin kasi this should be, yan. This should be 1646.7 over 0.75 yung given na efficiency. Horsepower na, convert na natin, BTU per minute. So, ang makukuha ay 51.77 horsepower.